So the first thing I did in order to analyze my code was import the necessary packages, which I did here. But first, let me run all the codes just to make sure everything is fine. Okay. So now I'll start by explaining the code. So the first thing I did was import all the necessary packages for the data preparation. I imported pandas, which would allow me to modify and visualize the data frame. Imported NumPy as well, which will help me with the numbers. And that's the next thing I did was import the data frame itself. As you can see, I called the data frame df, and this is it right here. Next thing I do is print the shape of the data frame, just see if I have any missing values, the type, the category type, the value types of my data, and the different columns you can see here. Then the next thing I did was create a copy of data frame in order to avoid modifying the original data frame. So as you can see, it's given by df copy, which is a copy of the original data frame. Next thing I did was I extracted different values from the month column. So this is where I actually started cleaning the data. So first thing I did is print the unique months. So that's what's given by this code. So unique months is equal to df copy months dot unique. This prints the unique months. The next line of code basically converts the months from objects to categorical data, because that's what I want to do. Because when I first printed the info, it was all objects, but I don't want it to object. I actually want it to be an integer, but the steps I took means I have to first convert it to a categorical data type before I can convert it to an integer. So after I converted it to a category, as you can see, I just printed it to make sure everything is fine, no missing values, everything is cool. Next thing I do is map the numbers of the months. I try to encode the month column. That's what I basically do. So I assign all the months that are present numbers, and I apply the mapping. And as you can see, with this line of code, I simply replace the original months column with the mapped months. So now, instead of it going to be reading the normal categorical data, it's going to be reading numerical data. So like February to December 12, November 11, stuff like that, like we see over here when it prints the results. Yeah. And so moving on, after I was able to do that, I then changed the value type to an integer, because now it's numbers. It doesn't need to be category anymore. So it's all numbers, integers. And the next thing I do is also check the different unique values in the Vista type column. And as you can see, there's like 3 different types: returning Vista, new Vista, and other. Now with this, unlike the month mapping, I can use label encoders, because it doesn't really matter what kind of numbers it assigns the different Vista types, because it doesn't carry any weight. Yeah, so that's what we do here. We encode the Vista type, and then the next thing we do is convert the weekend and revenue columns into integers. They are currently Boolean, and this code would convert them into integers. Yeah. And I finally just print the info again on the data frame, just to see the shape, make sure everything is in the right data type I want. As I can see, there's no missing values, and we have all our columns still available. Okay, so the next thing I do is I try to see if there's like any ranges in a data frame, because if there's any huge ranges, I'll have to standardize it. So it's given by this. So as you can see here, I can see the count, the mean, standard deviation, the min and max, and I can see that it's very the ranges are very huge. So I would have to scale the data basically. So what I do is to scale the data, I just try to scale the features and exclude the targets column to revenue. So all the columns apart from revenue, which is given here, and I call upon the standard scaler, which I got from the sklearn package in order to do it, and I scale the whole thing, all the feature columns. It's given by this code. The next thing I do is print the statistics of the data frame again, of the scaled data frame, to make sure everything is the mean and standard deviations are between 0 and 1. And as you can see, in fact, everything is between 0 and 1, or at least close to 0 and 1 for all the columns. So which means I can move on towards the modeling. So the first thing I do in preparing for data modeling is I first define what the X is and the Y is. So for the X, I use the scaled data frame which we have. So it's basically all the columns with our revenue that are scaled. And for the targets, I use the revenue column. So I just call on the column. I run that and it's set. And the next thing I do is I have to split the data set into training and test sets, which is given by this code right here. Right now, as you can see, the test size is 0.3 or 30%, which makes the target, the training size 70%. What this basically does is it allows the model to perform tests with 30% of the data and make predictions on the other 70%. The random state is set to 42. This make sure everything is balanced. Yeah. And the next thing I do is run the smooth to compensate for the oversampling, because our data frame has is trying to predict target column revenue, but we tend to have more zeros, more class. So we have two different classes in the revenue, class one and class zero. Class zero means they don't make a purchase, and class one means they make a purchase. What we are trying to do is make sure that this is balanced. So the number of people that make purchases and the number of people that don't make purchases are balanced. So Smooth basically generates synthetic values for the minority class in the target column. So that's what this whole code does. It's just trying to compensate for oversampling. Once that is done, I can move on to the model. So the first model which I chose to do was KNN. I set the hyperparameter to 19, n equals to 19 neighbors, and I run the code. And I'm just gonna see for the KNN, I have an accuracy of 87%, which is not bad at all. But what I'm trying to do is looking at the confusion matrix. You can see that the class 0 actually has higher precision and recall as compared to class 1, which has 0.75 and 0.32 recall. Now, I hope for the other models I'm going to run, they give me better predictions for class 1, because that's what the whole analysis is trying to do, make more better predictions for class 1. So I make a confusion matrix for the KNN, and as you can see, based off the predictions, it's able to predict correctly more of the time if they don't make a purchase. But what I was trying to actually do was make sure they actually predict that they make purchases. So actually 1-1. So because 1 means they make a purchase, 0 means they don't make a purchase. And as you can see, it predicts 186 times that they make a true purchase, which could be better, I would say. And moving on to the random forest, the other model I chose to use. This is random forest is way better for in analyzing data sets with huge data. So I'm hoping to see better accuracy results here. And then as you can see, I set the hyperparameters for the random forest here as well. Then I run it, and as you can see, we kind of get a better accuracy of 87%, but the precision and recall for class 1 is still not the best, but it's better than for the KNN, because recall here is 0.83 or 83%, which means it's more confident in predicting class 1 than it was for KNN. And last but not least, I run the XG boost. What the XG boost also does is it's also a predictive model, and then this also works well on very large data sets like what we have here. I also gave it a few hyperparameters to use, which is given here. Then I run the code. It also gave me an accuracy of 86%. And what I can tell by looking at this is that it doesn't differ that much from the the values we got from the random forest, it's actually is a bit better. Yeah, yeah. So as you can see, we run the confusion matrix here to get to see how well the prediction is being done. And I also run a dummy classifier just to make sure that just to see how everything works. So the dummy classifier is just something I obtained from the sklearn. And as you can see, this dummy classifier had an accuracy of 84%, but a recall of 1. This means that it just automatically assumes that everyone doesn't make a purchase, which is yeah, I mean it's just a dummy classifier. It's yeah. And the last thing I did finally was print everything together. So all the precisions recall and F1 score, so we can make a we can make we can uh we can actually decide what to use. And then from what we can see here, we can see that among all the accuracies, random forest has the best accuracy. It has the best precision and best recall, and as well as the F1 score, which means random forest would be the best in predicting whether a customer will actually make a purchase in our e-commerce store. Yeah. Do you have any questions?
Yes, I do have a few questions for you. So, I would like to start off by asking you, how did you determine your K value? How did you come to
Yes.
that?
Yes, the K value. Let me just go back up there. But yeah, to determine the K value was basically determined by trial and error. You know, I had to basically just keep trying different like K values between 1 and 30, but only the odd numbers to try and get the right K value. And I found out that the best value that I used to use was 19 because it gave me the best accuracy. Yeah.
What about the missing values? How did you handle the missing values?
Missing value. Yeah, so this data set didn't have any missing values.
All
We
right.
can see that from when we first run the df copy.info, we get to see that it has 0 missing values. The null counts as 0, no missing values. But I still had to clean it by converting some of the data types to different like data, like I had to convert objects to integers, stuff like that. Yeah.
All right. And then converting your categorical data, you already explained that. I would also like to ask you, why did you choose these models?
Okay. I chose the KNN model.
And
Uh,
also, which one of them did you like the best? Which one of them offered the best accuracy for you and overall was better to use?
yeah. Uh, the KNN model was actually chosen, wasn't actually chosen. I had to use it, but then I found out that the data sets we were given, the data set we used would also work very well with the KNN. So that's why I used it because KNN works well with numerical values. So I was like, hey, why not just try it? And for the XG boost and the random forest, they work very well with high dimensional data or like data that has like a lot of values, like a lot of columns, a lot of features, a lot of rows. Now these are very good at like making like accurate predictions. That's why I went with these models. Yeah.
All right, then. Thank you very much for your work. I think everything was done pretty nicely and everything was quite straightforward as well. And yeah,
All
everything was done and delivered really nicely.
right. Thank you. Thank you. Let's move on to evaluating your data set.
Perfect. Let's do that.
Run everything, just to make sure. All right.
All right. So let's start from the beginning. Okay, so what I did in the beginning is that basically I just imported all of the necessary libraries that I needed. So I used Panda to handle the dataset, Matplotlib, Seaborn for the visualizations, and all of the other packages that I needed as well. In
Mhm.
the second cell, I'm just doing a small description of the goal, of the business goal from the file that I chose. So the aim is to basically predict which of the users will make a purchase and which of them will not make a purchase. And moving on to the third cell. Perfect. So in the second cell or third cell, we can see here about the data understanding. So what I did here is that I just loaded the data set by using pd.read scv like always, and then I inspected the shape, the data types as well. I checked also for the missing values so I could understand better the structure before I would do any transformations, so that I would be able to transform the data from categorical to numerical. And then I cleaned and prepared my data. Then I cleaned and prepared my data. I took out all of the rows with the missing values so I could be sure that my models would not break or would just run smoothly, basically. Um, and then I encoded the categorical features into the integers using the label encoder. So that's what I used. And I did this in some sort of a loop in order so that I could avoid repeating the code for each and every column. So I just used the label encoder. And then moving on to yeah, stay right there. Here we can see the revenue. Since the revenue is a Boolean target, I converted the revenue to to 1.5 integers so I could make it more compatible with the classifiers that I used. And I did this so it would be easier for me to separate the features X and Y, as you can see also in the cell. Yeah, perfect right there. Uh, I scaled the features as well, so I could normalize them, so I could use them for my models for the logistic regression and also for naive Bayes. And then what I did is that I split the data into training and to test sets. So you can also see that right here. So like 75 and 25% basically. The test side came out as 0.25%, and then the test split as 75%. Moving on to the modeling. So for my assignment, I chose to do three different models. So we have the naive Bayes model, the logistic regression, and also the random forest classifier. And I put in also the coding so I could get the evaluation loop of these models. Um, I chose these three models for different reasons, but most importantly, I chose them because they're more easy to navigate than the other models. And then moving on to the evaluation process. So the naive Bayes named it as NB. The logistic regression you can see is LR, and the random forest is RF. So these are the names for each and every model. What I did is that I organized the models into some sort of dictionary so I could easily loop over them. And for each of them, I predicted a test set. I printed the accuracy as well and the classification for each and one of them. And I did the confusion matrix. Can you go down a little bit more, please? Yeah, perfect. So here I did the confusion matrix by using seaborn.heatmap, which gave me the visual insights for all of the models that I needed. It gave me for the naive Bayes we can move on to the accuracy that I got from each of the model. So naive Bayes gave me a 0.79 accuracy, which is nice. However, it could have been better, but it shows good precision. So it's as we can see here, it shows 0.93 precision, which is pretty good for naive Bayes. And then moving on to the logistic regression accuracy, it shows 0.87, or we can call it also 0.88. Precision is also nice. It's also nicely done. We can see here at 0.89, pretty good. The random forest accuracy scores 0.89, almost zero point 0.9. The random forest showed me the highest accuracy out of the three models that I chose, and it also showed me the most precision when it came to them, when it came to which one of them was more precise.
Yeah.
Yeah, so this is my script. Do you have any questions for me that you would like to ask me?
Yeah. I'd like to know how was the data split for the training testing?
Sorry, can you repeat one more time, please?
Like the data for the splits when you splitted it for
Oh,
the
yeah, the
testing.
data split, the data
Yeah.
set split. So I split the data. Could you take it there, please? Yeah,
Yeah.
perfect. So the way that I split the data is that I basically used train underscore test underscore split. I used this on my code with a 25% test size and a fixed random state of 42. So it gave me the result that I needed.
Mm. And
So I basically just used on my code the train test split and also the random state, which was already given to me for reproducibility.
yeah, yeah, yeah. I think I just asked that question because I didn't notice it because it was like here. I think maybe next time you can put in a whole new code cell, make it
Yeah, that would be a nice idea.
yeah. I think I also have another question about the parameters. So like what other parameters could improve the performance of your classifiers?
Um,
Like for
well,
example, the random forest classifier was initiated with only random state 42.
yeah. So what other parameters I could use to improve its performance, you mean?
Yeah, exactly.
Uh, well, I guess I would include the number of the trees. I would also include the maximum depth.
Okay. And
So
estimators. Okay, cool. Yeah.
and maybe I would also control maybe the complexity that I would get by it by using grid search CV or
Mm,
maybe randomized search CV, so it could give me an optimal performance, so a better performance in utilizing the codes.
okay. Okay. And then the last question I have is why is your classification report printed inside the model loop?
All right, so well, placing the classification report inside of the loop allowed me to display a more detailed performance metrics. So, like, it gave me better precision and better score overall for like each of the models immediately right after evaluation, right after I used it. So it helps quickly, basically, with understanding each of the model's strength and focusing on them, and also the weaknesses in terms of the class prediction. So like beyond just accuracy. So like it's more than just accuracy.
Okay, okay. That makes sense. Yeah, okay. I think this is very informative. Thank you for
Thank
sharing.
you as well for your evaluation and for your questions.